Well, hello there, Danny. Today we are going to talk about the number line. It's going to be awesome. Um, let's start with this. When the whole class is fighting over whether the answer is 17 or 18, but you got 157. Have you ever felt like that before? I know that I have, so I'm just going to fess up right now. All right, if you haven't already, go ahead and pause this and do your facts practice. It's test A again, so 64 multiplication facts. Last time you got 100%, but just, time yourself and see how you do this time, okay? All right, when you come back, we are going to start with mental math. So do all of these in your head, and I gave you some wonderful astronaut pictures so that you can sort of relax and get these done in your head, okay? The first one is 5 score. The next one is 10 dozen. Then do half of 500. Okay, problem D, 350 plus 400. The next one is 50 times 50. And F is going to be 400 divided by 10. All right, let's see how you did with those. And then G. G is an interesting one. Okay, so this is the one you're going to do in your head, all right? We are going to start with the number of feet in a yard. So I think you know what that is. How many feet are in a yard? We're starting with that number. Multiply by 12. Divide by 6. Add 4. Double that number. Add 5. Double that number. Then double that number. Okay, what is the answer? Hopefully you got that right. If you need to listen to it again, you can go ahead and skip back. But I'm going to move on to problem solving because Houston, we have a problem and we need Danny to fix the problem. Here is the problem. This one is a little tricky. Let's see how you do. It involves dice. Just one. I guess it's called a die. I don't know. When it's singular. What's it called when it's singular? Text me and tell me the answer to that. Anyway, Simon held a dot cube so that he could see 3 faces. So just like in this picture, you can see 3 sides of it. He could see 7 dots. How many dots could he not see? All right, I'm not going to give you any clues on this. I'm just going to let you figure it out on your own. I'll be interested to see how you do that, okay? Pause this video and go ahead and do that. And I'm going to move on to the new concept, which is the number line. I know this is not a new concept to you. You already know how to do this. But a number line is something that helps us to arrange numbers in order. Every number has a unique spot on the number line. The 0 point of a number line is called the origin. So there are a few vocabulary words for you to know. That's one of them. Origin is the 0 spot. Okay, the numbers to the right of the origin are positive numbers and they're all greater than 0. Every positive number has an opposite that is the same distance to the left of the origin. Okay, so the numbers to the left of the origin are obviously called negative numbers. Negative numbers are all less than 0. And 0, what is that? Is it positive or negative? It's neither. It's neither one. It's nothing. Okay, on this number line, the tick marks indicate the location of integers. So this is a new vocabulary word, integers. It's all of these numbers, okay? And we've already seen set of sequences, which are natural numbers. That's where you start with 1, 2, 3, 4, 5, just like you're naturally counting. Those are also called counting numbers. If you add 0 to that, and then count all of those are called whole numbers because whole involves the number 0, like a whole. Now we are going to learn integers. Okay, so integers are all the digits on a number line. And then this, okay, remember these dots on either side are called ellipses. And that indicates that the number, it's an infinite. It goes on forever in the positive direction, and it goes on forever in the negative direction. Notice that all of the negative numbers have a negative sign, so you already know what that means. And positive numbers you can write them with a positive sign, or you can just leave it off. If you leave it off, you assume it's positive. Okay, as you know this already, if we're starting here at 0, as you move to the right of the number line, the numbers get bigger and bigger, greater and greater. As you move to the left on a number line, let me do that again. As we move to the left on a number line, the numbers become less and less. So a number is bigger than another number if it is more to the right on a number line, right? So -2 is bigger than -3 because it's to the right on the number line. So the farther it is to the right, it's bigger. So when you compare two numbers, like this lady, she wants to compare two things. When you compare two numbers and you want to know which one is greater than the other one, you can decide which one is to the right and that one's bigger. And then you would put a comparison symbol. And you remember what those are. A comparison symbol is like this. This for less than. You can remember that because it kind of looks like an L, less than. So -5 is less than 4. What about this one? If we're comparing 3 plus 2 and then we're comparing 5, it's obviously equal. So that's one of the comparison symbols that you can use. The other comparison symbol is greater than. I remember greater than because you can make it into a capital G. Greater than. Okay. And it's greater than because 5 is to the right on a number line. So this is the bigger one. The alligator eats the bigger number. Okay. All right, let's do example 1. I know this is going to be easy for you. Arrange the numbers from least to greatest. So they gave us 3 numbers here, but they are not in order and we need to put them in order. That's all they want us to do on this problem. So the most negative number or the smallest number is -2. So I'm going to change that and move it over here. And once I've done that, it turns out that they're all in order after that. So I can just erase that last comma and this is the answer. I think you know that one already. All right, example 2. Put in the correct comparison symbol, and then we have to use words to write the comparison. So that's what they want us to do. So they want us to compare -5 and 3, which is a bigger number. Obviously, I think you know this. The 3 is bigger than -5 because it's to the right on the number line. So the way that we would write that in words, because they said to write it in words too, let me get a different color so you can see what I'm writing. I'm going to say -5 is, oh, I forgot the symbol. Oh, no, I did right. It just disappeared. -5 is less than 3. Okay, they said to write it in words, so I wrote everything out. All right, let's jump into example 3. Show this addition problem on a number line. Did you know you can also do math on a number line, not just points? So we can do math, and this is how you would do it. Here's the number line. It goes from -6 to +6 over here. Here's the origin at 0. So we actually are going to start at 0. And then first we draw first we draw the number line, then start at the origin, and then draw an arrow to the right for the first number. So the first number is 3. We draw this arrow. Do you see that? So we go 3 spaces to the right. 1, 2, 3. Okay, we did that. And then from that arrowhead, from wherever you stopped, then you're going to draw a second arrow that's 2 units long because we're adding 2. So it wants 2 more units, and it's also to the right because it's a positive number. So we start here, and you typically go up so you can show this next spot and then go 2 more spaces. And then you end up stopping here. If you ... all the way down, you see what the answer is, and the answer is 5. And that's 3 plus 2 equals 5, but it's shown visually on a number line. That's all you do. Boom, easy as that, right? Let's do the next example, example 4. It says, show this subtraction problem on a number line. All right, pay attention to these because even though it seems easy, it's about to get super tricky, and it's helpful if you know how to do the easy ones. So first you draw the number line again. The next thing you're going to do is start at the origin. And then we want to start with the number 5. Are we going to go to the left or to the right? Well, this is a positive number, even though the positive is not written there. So we're going to start at 0 and then go 1, 2, 3, 4, 5. So this first arrow represents the 5. Now you want to minus 3. So we're going to go up, 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 dot, dot, dot. Okay, to draw our second line. The second line is 3 spaces. Is it going to be to the left or the right? It's going to be to the left because of that negative sign. So 1, 2, 3. And we stop there. And if you dot, dot, dot all the way down, you end up at 2. 5 minus 3 is equal to 2. I know you could have done that in your head, but that's how you would show it on a number line. Okay. I like a challenge. Let's step it up to the next level, right? So let's do example 5, and it wants us to show this subtraction problem on a number line. This one's a little trickier, 3 minus 5. No problem though, we just do the same thing. We start at the origin. Okay, our first line is going to be 3 to the right because that's a positive 3. So it's going to be 1, 2, 3. So we draw this arrow, then we go up, dot, dot, dot. And now the next number is going to be 5. Is it to the left or to the right? Well, since we're subtracting, that 5 is kind of like doing negative 5. So we're going to go 5 to the left. 1, 2, 3, 4, 5. And we end up here. Our answer is going to be negative 2. Oh, I didn't do it right. Equals negative 2. That's the answer because that's where we ended up on the number line. Now, I want to show you something about these two problems, okay? We just did 5 minus 3, we got 2. Remember that subtraction is not commutative. So if we switch around the order of these, we get a different answer. 5 minus 3 is 2, but 3 minus 5 is negative 2. What do you notice about those answers? 2 and negative 2. They're opposites on a number line. The opposite of 2 on a number line is kind of like if you're in I was going to say the underworld, but only Addie would know that reference, so sorry. 2 and negative 2 is opposite. So when you reverse the order, it gives you the opposite difference. That's why, I know, are you shocked by this? This is a shocking revelation if you didn't know this before. But since subtraction is not commutative, it turns out that when you switch the order of subtraction, you will get the same number, but it'll be the opposite. It's like Bizarro world. See, so 5 minus 3 is 2, 3 minus 5 is negative 2. And that works for different subtraction problems. In fact, it will make the last example super easy for us. Let's do example 6. And they want us to simplify this problem. Okay, so this could be a difficult problem, but I want you to imagine that number line in your head. And here's 0, and you're going to go somewhere like 300 to the right, and then you're going to draw the next dot, 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 and the next line is negative 840 all the way somewhere over there. And you're going to end up with a negative number for that problem. You know you're going to go past 0 again because this is way bigger than that. So knowing what we just learned in the previous problem, that subtraction is not commutative, and that if you reverse the order, you get the same answer, just the opposite of it. What can we do here? We can make this a lot simpler, and we'll just do 840 minus 376. And then whatever answer we get, let's just take the opposite of that and make it easy, right? Let's try it. Okay, so 840 minus 376. You know how to do the math on that, so I'm just going to rearrange it so it looks a little different. Okay, let's start with the ones place. 10 minus 6, we're going to have to borrow. So let's borrow from that 4, make it a 3, make that a 10. Now I can do 10 minus 6, and I get 4. Okay, now I'm going to do the tens place. 3 minus 7, oh my, I'm going to have to borrow again. Borrow from this 8, make that a 7, and make that a 13. 13 minus 7 is going to be 6. And then we finally get to the hundreds place, 7 minus 3, and we've got 4. The answer is 464. But is that the answer? No, we have to do the answer to the original problem, which is the opposite of 464. And all I have to do now is make this negative. The answer is negative 464. Bam! Did you like that one? It was like all leading up to that last example, which was freaking awesome. All right, hope you enjoyed this lesson, Danny. Love you. Bye.